In this video, we look at permutation questions where the arrangements are done in a circle. In circular arrangements, there's no start and finish, so to count the arrangements, we need to fix one of the objects as the starting point and count from there. Let's take an example. In how many different ways can Amber, Bindi, Corinne, and Diane be seated in a circle? Well, we're going to start by locking in Amber at the top. The next girl around can be one of three possibilities, followed by 2 in the bottom spot and 1 in the last spot. By the multiplication principle, we have 3 factorial possibilities, or 6 in other words. Because we always lock in that first place and we actually don't count it in our multiplication, the rule for the number of arrangements in a circle is always going to be n minus 1 factorial, where n is the number of objects in our circle. Let's look at another example. In how many ways can 4 students and 2 teachers be seated in a circle if the 2 teachers have to sit together? We have to use our circle arrangements property, but also keep in mind that the 2 teachers have to stay together. We have 2 teachers, so we're going to consider them as 1 unit. This means in total we have 5 units, 4 students and the 2 teachers. Let's have a look at them around the circle. If we lock into place one of our positions, then the next person around to the right can only be one of 4 people. Continuing this around the circle, we can only have 3 possibilities, 2 possibilities, and then 1 possibility. So when we're working out our arrangements, we know that in a circle it's going to be n minus 1 factorial, or 5 minus 1 factorial. But because we've got to keep those 2 teachers together, and every time we move the teachers they could either be first and then second, or second and then first, we have to times our arrangements by 2. This means that the number of arrangements will be 4 factorial times 2 factorial, which is 48 different permutations. But it's not all multiplication. Sometimes addition is required. Let's look at example 10. How many numbers greater than 6,000 can be formed using the digits 3, 4, 6, 8, and 9 if no digit can be used more than once? To solve this, we have to think about what kind of combinations are going to make the number greater than 6,000. Well, we can have a 4-digit number, which can be anything that starts with a 6, an 8, or a 9, or a 5-digit number that starts with any one of our numbers. For our 4-digit numbers, there's only a possible 3 numbers that could go first, the 6, the 8, or the 9. For every number after that, it could be any one of the ones that is left over. So our second number could be one of the 4 left over, followed by one of the 3 left over, followed by one of the 2 left over. With our multiplication principle, timesing them all together, we get 72. However, there are 5-digit numbers also. If I want to make a 5-digit number that's greater than 6,000, I can use any one of my 5 possible numbers, followed by any one of the 4, 3, 2, or 1 that are left over. This is just 5 factorial, which is 120. So now what I have to do is I have to add up how many 4 digits of numbers I have, and also all the 5-digit numbers I have to answer my question. And I get 192 different arrangements. But this question puts a restriction on us that no digit can be used more than once. I'm going to give you the opportunity to try one where repetition is allowed of the numbers. Take the time to pause the video now and try it for yourself. Okay, here we go. We still have 4-digit numbers and 5-digit numbers. The only 4-digit numbers that are going to be bigger than 6,000 are going to start with a 6, an 8, or a 9. So there are still only 3 possibilities for that first number. But for the other 3 numbers, it could be any one of our 5. So for our 4-digit numbers, our possibilities are going to be 3 lots of 5 to the power of 3. As for our 5-digit numbers, well, all 5 numbers are possible at all 5 different spots. So we're going to get 5 times 5 times 5 times 5 times 5, or 5 to the power of 5. Again, we're going to add our answers together to get the total number of possible numbers that are allowed. And we get a total of 3,500 arrangements. I hope you got that, and I hope you're looking forward to some more questions. Good luck.